All right, geometry students, this is another one of the best, most important lessons you're going to have and you're going to need for the rest of this chapter. Algebra 2, a lot of pre-calculus, calculus. And if you can get this to be something that you just look at and answer, well, you're going to be golden. So we need to be on page 472. Special right triangles, chapter 9, section 2. All right. So you need to turn to page 472 and 473 to copy these down. Now, we should have repeated 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, and 9, 40, 41. Thank you, Mr. Goldman, a lot. But you also need to repeat x rad 2, x rad 3, 2x, x rad 2, x rad 3, 2x. Just repeat it. Just say it. Because eventually you're going to regurgitate the answers. So if we have a 45, 45, 90 right triangle, the sides across, opposite. If I back you into a corner and you're stuck in this corner and you're looking straight out at the wall, across from you is just x. It is whatever number it is. And the side across from here is the same number. And guess what? The side that's across the hypotenuse, the side that's across from the 90 degrees, that's always the largest. Whatever number these sides are, slap a rad 2 on behind it. We'll get to an example later. 30, 60, 90, x rad 3, 2x, x rad 3, 2x, x rad 3, 2x. All right, we have a 30-degree angle. We have a 60-degree angle. Now, whatever's across from a 30-degree angle is going to be the smallest side, and that's just going to be x. Across from the 60, however, it's going to be a little bit bigger. That's going to be whatever number this is with a rad 3 behind it. And then finally, the hypotenuse across from the 90, of course, across from the biggest angle is going to be the biggest side. It's going to be that first angle multiplied by 2. All right. So remember, across, you have to picture yourself in this corner, looking straight out to the wall over here. That's what I mean by across. All right. We need to start visualizing these. Okay. So let's see how we're going to use this. All right, these are the special right triangles. We could do the Pythagorean theorem, or we could regurgitate the answer like 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, x rad 2, x rad 3, and 2x. Okay, so at the bottom, page 473, here's number 1. Now, you are going to draw it with me. Just trust me that I know what it takes to get an education. Okay. What do we know? All right, we got a triangle. I see 2 of the same sides here, which means it's a 45, 40. It's an isosceles triangle. This is 90. These have to be 45, 45. Now, what do we do? All right, here's the thing. What did I say about this side? This side across the hypotenuse, across from the 90 degree, is the number, the length of these sides with a rad 2 slapped behind it. Well, wait. So ignore the rad 2. What's the number in front of the rad 2? It's 2. So what does x equal? X equals 2. So we have a 2 rad 2, 2 rad 2, x rad 2, 2 rad 2, right triangle. Let's do number 2. Ooh. All right. Some math is going to be involved. It's not always regurgitation. We're in high school here. But let's only use our brain when we need to. Let's rest it. What does it look like? Let's see. I got 2 sides that are the same. Must be a 45, 45, 90. All right. Now, what did I tell you to do? These are the same, right? So to get the hypotenuse here, take a side and slap a rad 2 behind it. Now, you're not going to leave this as the answer, right? So y equals rad 2 times rad 2 is rad 4. What's the square root of 4? Don't give me a plus or minus. This is an actual triangle. Y equals 2. How'd I get the 2? I realized that these are the same sides. It must be a 45, 45, 90. 45, 45, 90. Notice I'm pointing at the sides, not the angles. So how do you get the hypotenuse? You take a side across from the 45 and you slap a rad 2 behind it. So there we did it. Took the side, slapped a rad 2 behind it. I did a little bit back. Okay, similarly, for number 3. Okay. And again, if you are just writing the math down and you are not pausing and writing down what I'm looking at, all the words, or at least the words that make better sense to you, you are not learning this. You're just staring at it like it's a Netflix show. Ooh, interesting. So it definitely is a 30, 60, 90, right? What is across from the 30, right? If I back myself into this corner, across from the 30 is rad 3. So what am I looking for here? I'm looking for the side that's across from the 60. Well, at this point, since you haven't really memorized x rad 3, 2x yet, you're going to see, all right, well, across from the 30 is some number. To get the measurement across from the 60, I take that number and I slap a rad 3 behind it. So even though it doesn't look great, we have a little bit of practice already. This is going to be rad 3 with a rad 3 behind it, right? Take this number and then slap a rad 3 behind it. Yes, very fine. Rad 3 times rad 3 is rad 9, and we know the square root of 9 is 3. That's what x is going to be. Ooh. Let's see. Thought process. What do you think? What do you think the hypotenuse is going to be? X rad 3, 2x. X rad 3, 2x. All right. I'll do one more from the book, and then I actually, since I'm in my classroom, as you can tell, I got a worksheet for us. Oh, I know, right? Seriously, if you can look at this and answer it, and then wait to do a little bit of math if you need to, you're good. Number 4. You should be doing this with me. The more you draw, the better idea you have. You start doing this without thinking too hard, and that's a good thing. Ooh, God, to find the height here. What is this? What is this? All right, so I'm looking at this, and you know what kind of triangle it is? Equilateral, right? 4, 4, and 4. That doesn't help us at all. But we know this is 90. We know that this is 60, which means that this is 30. Here's another way we knew that. This is 90. This looks like it's across from the smallest side, and this is double. So we have an x and we have a 2x, and we know it's a triangle. Dun, 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 dun. We have an x and we have a 2x, and we know it's a triangle. That means this is our missing side. So we have an x, because it's across from the 30. We have a 2x, but we're looking for h. So do I care about 2x right now? No, that's just confirming that I know that I made a 30, 60, 90. So what is h equal to? It's x with a rad 3 behind it. So h is equal to 2 with a rad 3 behind it. Done. That's it. All right. So recognize it. Speaking of which, I'm not going to do the whole worksheet with you. Don't worry. You're going to have plenty of practice. But I want you to take a deep breath. I want you to do these as fast as you can with me. Let some of them be confusing. Just let it happen. All right. But take it in, like soak it in. We have a 45, we have a 90. So of course we know that that's a 45. Across from the 45 is a 2. That means that this is also a 45. So across from the 45, so that's 2, right? And you should repeat it with me. X rad 2. X rad 2. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41, X rad 2, X rad 3, 2x. All right. Even I need to take a deep breath from that. 45, 45, 90. Ooh, we know the hypotenuse is 5 rad 2. The across from the hypotenuse is x rad 2, x rad 2, 5 rad 2, x must be 5. Now, that's the general x. Specifically, though, this x is 5, and this y is also 5. 5, 5, 5 rad 2, x, x, x rad 2, 5, 5, 5 rad 2. All right, this one involves a little math, but let's go see. Oops, we only have one 30, 60, 90 on this worksheet. So 30, 60, 90 right here. This is the 60, that's across from the 60. This is the 30. Ooh, oh no. Oh no, math is involved. Darn. Okay. Math's involved, which means I think we should make a list. And this is a good skill. If you need to use this skill, please use this skill for your education. Across from the 60 is the 2, right? We see that, right? We see that, okay? Across from the 60 is a 2. Across from the 90 is this x. I hate variables. And this is y. Now, what's it supposed to be? Across from the 30 is supposed to be a number, and then across from the 60 is supposed to be a number rad 3, and across from the 90 is supposed to be 2 times that first number. So we made a chart. X, x rad 3, 2x, 30, 60, 90. What's the template? What are we looking for? What do we have in front of us? You can organize it how you want, but these are all the 60s for this problem. Okay, that means that x rad 3 is equal to 2 in this case. Ooh. So I need to solve for this x, which is not this x, by the way. I know. Welcome to math. How do we do that? We divide by rad 3. Ooh, and then do you remember from that beginning of the chapter video that I made? We're not allowed to have a radical in the denominator. So I got to multiply by rad 3 over rad 3, right? I got to multiply by the denominator over itself. 2 rad 3 over 3, right? Rad 3 times rad 3 is 3. 2 rad 3 is 2 rad 3. So this is this x, which is this x, which is this y. And at this point, your eyes probably just like glazed over. Sorry. That's okay, though. You can handle it. You're in high school. You just have to be exposed to it. So what's the y in this scenario? It's 2 rad 3 over 3. 30, 60. Now, how do I get the 90? I take this and I multiply it by 2. Oh, well, guess what, kids? If this is 2 rad 3 over 3, well, guess what? This is 4 rad 3 over 3. All right. This was tough. Good job for getting through it. You're obviously going to have some problems to do. You better rewatch this video and start writing notes to yourself, because if it is just math, then you are not going to be able to answer this stuff easily next year. And next year in Algebra 2, it should be regurgitated, not thought about.